It's about the frame. Hello everyone, Adam here from CRT, and today we're looking at the frame, you know, the bit that holds the other bits, but has some bits on it as well. An episode on the frame sounds really boring. Oh well, we're doing it anyway. Smile and then it will be really exciting. Let's not waste any time. Let's not waste any time by saying, let's not waste any time, because that's a waste of time. The start of any frame is going to be knowing what size you must contain. I'm going for a 250 cubed build volume, so the frame will be based off of that. I'll start by having an approximate size frame, fitting the components in and seeing what build volume I get from that size frame. I can then enlarge the frame and that will basically give a concept of what size it might need to be. One of the final features I want to have of the printer is for all the components to be contained within the frame. So this means the sides of the frame and the top, well maybe not the top, but the sides of the frame and the bottom are going to be the extremities of the dimensions. That means that if I need to make an enclosure, I can do that very easily just by adding panels to the sides without interfering with the internal components. If I have things that, like steppers that stick out the side or belts that go outside the frame and things like that, it's going to be much more difficult to build an enclosure, unless the enclosure is significantly larger than the printer, but I don't really want to do that. So the material I'm looking at for the frame is 2020 aluminium extrusion. I mean, everyone uses it, it's easy to get hold of, it's easy to use, it's easy to sort of design for, so that's what I'm going with. So the layout of the frame is obviously the next thing. To do the layout, you kind of need to know what the kinematics are going to be like, which is basically the way everything moves. I started looking at the Prusa i3, having a build plate on the y-axis that moves forwards and backwards, the z-axis which holds an x gantry which goes up and down, and then that x gantry which moves across the x-axis. Now, I found that quite difficult to fit to a frame and keep all the components inside. I mean, I could have done it, it wouldn't have been that hard, but I just wanted it to be a bit quicker and a bit easier. So in the end, I opted for the Core XY kinematics, which, if you don't know, is based on a rising and falling Z plate, which is the build platform, and then X and Y up the top. The interesting part of Core XY is the way the belt mechanism drives the X and Y axis. So after many hours of toying with different ideas, it came down to a box. It turns out this British T-slot frame seems to be different to everywhere else in the world. This gap is only 5mm wide, whereas everywhere else it's 6mm wide. What a pain. So I bought literally loads of nuts, like 200 or something. I was like, yep, because these are going to go everywhere. I might as well get a bunch because it saves me having to wait a couple of weeks if I need more. So I bought lots of those. I thought, yep, got them all. As they arrived, tried to put one in, didn't fit. You can see how the cross section matches this, and if it would fit, it would go in there. So I decided to print one. The difference is this one actually fits. So that can now slide up and down in there, and it's sort of the same size as this. The problem I was having with this is it's quite short, so it wasn't very strong. As I was tightening it down, it eventually became loose, and the hole in the middle I also made slightly too large. So second design I did, slightly longer. Again, very similar to the cross section of this one, just slightly narrower to fit in here. So these work quite well, but the problem with this bracket fitting onto here is these little things in the bottom. They catch on here, so if this, because this is so thick, it doesn't slide across it easily. I mean, I could cut the corners, the little, you know, these, off of every single corner bracket, but I didn't really fancy doing that because there's, well, it's quite a lot. So I did need those to get a bit thinner, but before I did that, I tried printing them the other way around. It broke. So that just sort of goes to show how important it is to print things in the correct orientation. The next thing I looked at doing was making a nut similar to this. I took one of these ones and cut it down to the point where I could sort of fit it in the end. So I sort of twisted in there. It just about, if I use the very end, there you go. So, but I thought this is definitely a different shape to the end of this. why don't I try and make something that's the same as this? So I did. You can see how those end sections are very similar. And what we've come out with is one that fits like that. It does need a little bit of, there you go, gentle encouragement, and it slides in quite nicely. The downside is because it doesn't centre, it can be quite difficult to get the screw in sometimes, especially when you're sort of limited for space, or if you've got it this way around, then it always sinks to the bottom and the screw's trying to go in at the middle. But for something that's essentially, well, the smallest fraction of a cost compared to the metal ones, I think it's worth it. So after testing these quite thoroughly, I found that they act a little bit like a nylock nut. Because of the plastic and the self-tapping nature of how I put them in, the plastic holds the screw tight. Well, that seemed to be the case, but actually they seem to come loose. I'm not quite sure how. Maybe it's the type of plastic, so I've tried a different plastic and a slightly larger design. But it was too strong. Too wide, too big, and it doesn't fit. So I shrunk it down slightly. It's now very similar to that one, but it is still slightly different. So now we have these end entry T-slot nuts, which work fantastic, and these can slide over, well, they don't really touch. It's just where there's imperfections in the plastic, it does touch. And then obviously I have this design as well. So there you have it. 2 plastic T-slot nuts. These might not hold forever because they are only plastic after all. I may have to try and embed a nut into the back, so I'll make a hex shape opening to put in a nut, and hopefully that will hold from the back using the plastic part to stop it spinning, and maybe that'll hold a little bit better. But I'll see how I go with these, because these are obviously very cheap to make, and very easy to make, and very easy to make lots of. So that's the slot nuts. So that's all there is to the frame, really. Some straight bits held together with some corner bits, held together with some plastic bits, and some screws. In the next video, I'll be looking at the X-axis, the gantry extruder, and the XY joining parts. Some of my favourite parts of the printer, actually, which is really exciting. I've loved designing that sort of parts. They're quite complex, quite intricate, sort of have bits going in and out and up and down all over the place. Perfect for 3D printing because the complexity is so high that to be able to like CNC it out of a solid block would just be, if not impossible, very expensive. So 3D printing, yay! Woohoo! Anyway, subscribe, like, thank you very much for watching. This has been CRT.